Hello, everybody. We are live here on the compiler's OMS CS class, and I'm here with both of our TAs, Chao as well as Yu Hong, and I hope all of you are doing well. And one first announcement is this: that from next week we'll try to do this hangout a little bit early, and I want to first check with our TAs if that's okay. Instead of doing it at this time, I know at least Paul was joining at a very late hour from Africa, um, and we want to try and do it. I promised him we'll try and do it a little earlier, and so we want to give it a shot. 2:15 p.m. EST. Do you think Yuhong and Chao, both of you, are you okay with those? With that?
I'm fine with it.
Yeah, it works for me.
Okay, so that's good. So let's give it a shot. Next week, 2:15 and EST, and we'll make an announcement. Can you guys announce it on the Piazza as well as?
Yeah, I will make an announcement.
So that is the first announcement I have. The second one is I hope all of you are progressing well with your projects. It's kind of critical to stay the course there because there's a bit of work. And what we have done is to make sure we have put in a checkpoint in between wherein you have to turn in your part one of the project that we have assigned, which is the parser and the scanner, which should be very easy. You have to change the grammar, make sure it becomes LL1. So play with it and generate the parse trees, generate the errors, and so on. So that particular part for Tiger, you have to turn it in and also mention how far you are. So we want to see that you are on track. Of course, we are not going to give you a grade on it. You will turn in everything at the end of on the due date for phase one, and that is what will get graded. So make sure, guys, that you stay on track and turn it in. If you have any questions, then please raise those on Piazza or bring it live to our office hours, which are now. The second announcement is I hope you're all pacing the lectures and videos properly, and also reading the material from the book. And we don't have a midterm in our class, but we certainly have homeworks which carry a bit of a weightage, as well as we do have the finals doing this pacing as well as trying out the homeworks. And some of you did ask about what about the problems on the back of the book. We don't have, unfortunately, solution manual for this book, but you can check each other's answers and comment to check the solutions, and that is what we'll be doing. And I guess in terms of our pacing schedule, where should we be now? Let us see. Are we on the... We should probably be almost finishing the parsing now, correct? Lectures going there. Yeah, so this is our week number 4, which is ending. So which is exactly where we'll be doing changes to the grammar, making it unambiguous, making it non-left recursive, and then making it LL1. So the next topic is LL1 parsing for forthcoming week, and that will be the parser that we'll be seeing. But all the changes to the grammar, how to implement operator precedences, how to implement associativity, all these are important topics which you should have finished pacing this week, chapter 3. And now we should be ready to tackle the important class of parsers, which is LL1 parsers. And the main goal of LL1 parser is to use one token to predict the rule. And using the rule, we should be able to speed up the parsing quite fast. So that is what is coming up in next week. And yes, we have other parsers, but in practice, which is LR1, SLR1, etc. But in this class, we don't have time to deal with those. So basic LL1 parser, we are doing it. Those who are interested, probably I suggest they read the SLR's one parser, which is there in the Cooper's book. It's a different kind of a parser. It is bottom up, and instead of expanding start symbol to match the tokens, it does the reverse. It matches the right-hand side of a rule and reduces it to its left-hand side. And then the whole set of tokens are reduced to the start symbol. So that is the way the parser works. And it allows us to embrace some things which are problematic in LL1 parsers, such as if-then-else condition generates a parser issue. The language is not LL1. It's not even LLK for any K. That means if I bring K tokens, you will not still be able to decide on whether it should be if-then-else versus if-then type of a rule. Because I can always create an example in which we are in limbo in terms of decision whether it is if-then versus if-then-else, because they share the common prefix, and that prefix can be unbounded. And so you cannot really remove it, and that creates this ambiguity in terms of which rule to choose, and that makes it non-LLK. So if-then-else is an if-then when they're simultaneously present, which are there in almost all languages. The parser becomes non-LLK, and it becomes LR1 or SLR1. So that's just a note. So once we are done with the parser next week, then we are going to get into attribute grammars and semantic analysis and so on. So I guess I'll stop here in terms of announcements and let Chow and Yuhong say something about announcements and any kind of project-related things that they have, tips or whatever, and the homework-related issues, and then we'll be ready for questions. So, Chow?
I guess so. For the homework, there are a lot of students asked the NFA for that number question. What is problem? Let me check it out. Question 2, part 5. It was a huge DFA. Many students asked how to draw it neatly or clean. I know it's kind of hard, but one way to draw it, so it will end up with a huge DFA, definitely. You can combine some of the transition lines together which will make the graph looks cleaner. Yeah, that's just one part of the homework.
So what I also would suggest is this, that you can show some construction, and you can write that here will be some other edges in this particular way, but because it is so big, I'm not able to draw it, but here are some edges which will go like this. So it is okay to show some construction as much as you can, and also write that whatever you're not shown, how it will look. Okay, by sentences, that from this state to that state, you will have such and such types of edges and so on. That makes sense, Yuhong and Chao?
Yep.
Yeah.
Okay. Any other announcement? Yeah, go ahead.
I think for the grading part, the grading for homework 1 would be released next week.
What did you say, Chao?
Hello, can you hear me?
Yeah, I couldn't hear you earlier.
I mean, for the homework 1 grading stuff, the grading for the homework 1 will be released next week.
Right. It's due on February 5, right?
Yeah.
So today is first. I think it's due on Tuesday morning, EST, which is Monday night. This time we are keeping it AOE times, so hopefully it is going to help everybody. Once they get it, I think maybe the end of that week, end of next week, right?
Yeah.
We can try and release the grading. Okay. Are there any questions or announcements or anything?
No.
Okay.
Hello, can you hear me?
Yes.
Oh, yeah. I had a question regarding Project 1. In 2.1 for the lexical definition, there's a note that says keywords are recognized as a subset of the identifiers. So the scanner recognizes an identifier and then checks it against the list of keywords. And so if it matches, you return the keyword. If not, then you return whatever, I guess, user-defined identifier. So I was trying to think how that plays out in the grammar. If you have something like, let's see, I'm trying to think of find a good example here in the grammar. If you've got like the type declaration, where it's type ID equals the expression type. Does that mean essentially ID kind of can be like essentially any of the keywords, like main or what is it? Like it could be like main or comma or colon, and then the final option is essentially some regex that doesn't match those keywords, and anything else that meets the identifier spec. Is that correct?
Yeah, for the ID part, it can be any string, as long as it is not a keyword.
Okay, okay. I guess then that little note confuses me because it seems that the keywords are also IDs, is what I read this note as.
Yes, generally, I think keywords and any variable names, they are both IDs. But
okay.
ID contains like type ID, something key ID, something else. So when you define a new type, the ID can be any of strings, like not the key ID, just that there is no conflictions. So I think yours, yeah, I think your like semantic checking or grammar checking, you also need to check whether this ID is used, especially based on the scope of rules.
I see. Okay. Okay. I guess, and just to just make it a little more concrete, like I'm going to paste this into the chat section, but the first line in grammar is like your Tiger program expression. And it's because like main, let, in, begin, and these are all keywords. So would it look essentially like this, I guess? ID. Jeez, where's my... is that kind of what it is? I essentially just replaced all the keywords with ID, right? Because, or do the key, if it's a keyword, then we explicitly leave it as a keyword. But I guess an type ID needs to check to make sure it's a keyword first. So for something like this, we just want to check that the ID in the type of declaration is not a keyword. Is that correct? Is that the purpose of the note, I guess?
Yeah, so Joe, let me clearly answer this question for you to avoid any confusion. So typically what the lexical analyzer does is recognizes keywords as a proper subset of ID, identifier class, and sends it separately as distinct tokens though. So for example, for main, it will not send it as an ID, but it will send it as a separate token called main.
Ah, I see.
Okay. And so this is what happens. So this is what we wanted to say, that's the way the lexical analyzer should be implemented. First, recognize everything as an ID class, and then the special matching of that, if that happens to be main, then send a token called main. If it happens to be let, then send a token called let, and so on. So that is one thing.
Okay.
The second is, and this is something which we might have missed, is none of the keywords are typically allowed to be used as identifiers.
Okay.
So because given this particular way of implementation, you can see that main will never come as ID towards the parser, correct?
That's correct, yes.
And so that is an implicit sort of something which is said here, which is maybe unclear, is the keywords cannot be used as identifiers in the program because of the way this is implemented.
Oh, I see what you're saying. Okay.
So does that make sense?
Yeah, it makes sense now. I didn't make that. I didn't see kind of that kind of implicit specification, I suppose.
Right. So we should have probably been a little bit more clear also. But I just wanted to be sure that all the keywords are reserved words of the language, and they are sent as special tokens, and therefore they are not sent as IDs, and therefore cannot be used as IDs.
Got it. Okay. Thank you very much, sir.
Sure. Thanks, Joe. Any other questions, guys? These are the kinds of things which you might have missed, or something may not be clear. It's good to sort of get clarity on it. If you have anything else like this or anything else, let us know.
more thing regarding this deliverable. The makefile is supposed to be some build tool, right? If we use Java, so probably Ant or Marvin will use, right? Is that correct?
Yeah, for Java, you're allowing the Maven, and for C or C++, we're using GCC.
Okay, thank you.
I have another, I guess, practical Ant question. The Grun tool that only works if we compile the Java source files, right?
Actually, it also have C plugin, like generated C files, especially C++ files.
Oh, okay. Because I guess just from looking at the README, they're like, you use Grun, you specify the grammar you want to use, which I guess expression or rule you want to test, and then GUI. But whenever I generate, I guess C++ source files from the Antler command, Grun doesn't seem to work properly. But when I create Java source files and then compile those, Grun seems to work properly. Is there like a flag I can use that Grun needs to? Or I guess I got to compile. Does the output of the C++ source file like have to be somewhere specific? I guess I'm just confused on that.
Yeah, I think there is a command option specify the type of the generated file, the package.
Okay. And then okay, and then I just have to compile that, and then I guess Grun knows to look for that versus a Java Java object.
Yeah, I think this tutorial could be useful.
Oh. I'll set it here. Okay, yep. .cpp. Okay, CMake. Circle. This is a good tutorial. Yeah, okay.
All right, as we await some other questions, I guess I wanted to just quickly mention something about, I saw some postings about the pumping lemmas. So in this class, we are not really expecting you to know the pumping lemmas, but rather know the fact that if you had to remember some unbounded properties of the strings, then you cannot use a DFA or an FA. Just that intuition is expected for answering the last question in the homework. So many times you are faced with, and we did several examples on those lecture videos, although the string is very large in terms of its length, potentially infinite in length, the automaton has to only remember some finite property of the string. For example, parity is one example of that, which is just a 0 or 1 property. The other property could be in terms of whether it is a multiple, the length is a multiple of 3. Again, it's very easy that as we keep getting newer states, newer characters, we keep cycling, and we keep coming back to the same original state, which is divisible by the length by 3, for example. So these are the examples in which we are okay to just remember the finite property of the string, even though the string itself may be unbounded or infinite in length. However, that is not true for all kinds of different strings. And we also showed an example of 0n, 1n, wherein you really have to remember the exact number of zeros so that they can be matched with the number of ones. And this, as you can see, as n becomes larger and larger, if you have a DFA with certain fixed number of states, such as k states, is unable to remember a string of length n zeros and n ones, because the number of states are not sufficient to track this length of number of zeros. So this is an example why we get into a territory where the property of the string becomes unbounded, as here, as against the property of modulo or property of parity, which are bounded regardless of the length of the string. And that is why this particular string 0n, 1n is not, we cannot process it using the NFA or DFA. So use this type of intuition and use this type of reasoning to check on all the examples that we have given you, and hopefully that will help you answer it. Pumping lemma is a formal way of proving this, which is does something which is a contrarian type of a proof, but that is not really part of our class. If you're using those slides or examples, that's fine. You could also arrive at the same results in this particular way. So I just wanted to mention that.
Thank you.
Sure.
Chow, here's the example I was kind of referring to from the Antlers, like little getting started markdown document. But essentially that, right? If I essentially the Java compiler step, if I created my C++ source files, I would essentially do something like CMake something, and then it would be the same. Grun would still work the same way after that. Oh, I guess, yeah. Or do you always have to have the Java compiled object for Grun to work properly?
Huh? What do you mean by Java compiling Java to a CMake file?
Oh, I'm not. I'm sorry. I'm just that last thing is just that should be a substitution, because I guess if I generated my C++ source files from my grammar, my G4 file, I have to compile those source files, and after I compile them, does Grun recognize? Does Grun recognize that, or does Grun only recognize like Java compiled objects?
You mean the CMake?
Well, I mean, like, sorry, I'm not being very clear. CMake aside, in just this example here, they use, we generate Java source files using Antler4 hello.g4, and then we compile it using Java C, and then Run recognizes the output of the compilation process and then runs a little test for us. I guess what I'm saying is, if I had C++ source files and I compiled those C++ source files using CMake, does Grun recognize the output of that as well?
Yeah. Actually, they are just like for the C file or the Java file, just implement the same parser, following following the same grammar. Actually, just the like different language implementations.
Okay. Okay, cool. I just wanted to make sure. I just been just for the time being, I've just been making it Java because it's easier to do Java C. Thank you.
You're welcome. Ah, I made a mistake. I thought the homework one should be due at January 25th. It's until February 5th. Okay, we are set this time. So see you next week.